Hello everyone, it's Mr. Pogachnik again, and today we are going to start our guided notes in 5.4. Now this is going to split into two different videos. The first one is going to be a bit of an overview, and the second one's going to get more detailed about each of the planets. Now, what we want you to think about is the following. We want you to be able to understand the basic features of the terrestrial planets and the outer gas giant planets. Now, you may not know what those are yet, but hopefully by the end of the video, you will have a pretty good understanding of what they are. And a question to ponder, and at the end you'll have a couple more. What are the key differences between terrestrial and gaseous planets? So what are the things that make them different? How do we classify them into those two groups? All right. This is a little image that shows the Sun and the 8 planets in order. Now, we have already talked about the Sun. We know it's a medium-sized star, one of billions of stars in the Milky Way galaxy. Billions and billions and billions. It is the closest star to our planet. It is not far at all. Well, all things considered. And its gravity keeps all of the planets lined up in their orbits. Now, one thing to note, the planets don't actually look like this. This is not to scale. It's actually horrible. It's very bad. And they don't line up like that. They are actually very spread out in their orbits. But this does show the order of the planets. Okay, so what is the difference between a planet and a moon? So sometimes we talk about moons, and sometimes we talk about planets. Planets orbit the sun, while moons orbit a planet. So the planets go around the sun, the moons go around the planets that are going around the sun. So we live on the planet Earth, and it orbits the sun. The moon orbits the Earth. So where are we located? We're located in our own solar system, which consists of the sun, our local star, and at the center of 8 planets orbiting the sun. So our star is a huge sphere of hydrogen gas held together by gravity. Now, we've already talked about this a little bit in the previous section. We talked about what the sun is, how it's powered, etc. And that is our star. The sun is our star. And here again, we have another image that is not to scale, but it does show the planets. It shows the inner 4 planets and the outer 4 planets, separated by a little rocky boundary that is known as the asteroid belt. Now, when we talk about distance, we talk about things called astronomical units. This, again, is review, since it's been mentioned, but we will mention it over and over, so it really drives home what an astronomical unit is. It's the average distance from the Earth to the Sun. It's about 93 million miles. And as we mentioned before, it takes almost 8.5 minutes for light to get from the Sun to the Earth. Okay, so a very quick overview of terrestrial planets versus gas giant planets. So, characteristics of the 8 planets in our solar system. The terrestrials. So here are a few things that make terrestrial planets, and you can see the 4 in order. So they are Mercury, Venus, Earth, and Mars, and they go from left to right in the image. They typically have very rocky crusts and dense mantles and cores. So like on Earth, we live on the rocky crust, and we've talked about that in previous chapters back in, the first part of the year. We live in the crust. Other planets, other terrestrial planets, are the same. We encounter plate tectonics, so the outer crust is cracked up and it moves around a little bit. We have volcanoes, we have weathering and erosion, and we have impact cratering. Now, a planet like Mercury will have less weathering and erosion because it doesn't have much atmosphere, but it will have a lot more impact cratering. It looks a lot like our moon. We are all close to the sun, and we're close to each other. So the 4 terrestrial planets are actually pretty close to each other, relatively speaking. We all lie within the first 1.6 astronomical units from the sun. When you get out to the gas giants, the distances increase. So, characteristics of the 8 planets. Now we're going to look at the gas giants. They are Jupiter, Saturn, Uranus, and Neptune, and they go from left to right. And you'll notice that Jupiter and Saturn are considerably larger than Uranus and Neptune. They're made mainly of hydrogen, helium, and other gases. You may notice that that's similar to the sun, that it's made mostly of hydrogen and helium. This is similar. So these gases got trapped by these planets. Now they're very large, very massive. Jupiter is the most massive in the entire solar system. Very large. They have very dense atmospheres. And you can see that they have what looks like clouds or something on the outside, those different colors. Those are actually clouds that are moving. And they are far from the sun and far from each other. They are a long ways apart from each other. We're talking up to, 10, 12 astronomical units between, Neptune and Uranus. They are way out there. They extend all the way out to about 30 astronomical units away from the sun. Now, beyond that, there are other things. So what we have out there is Pluto, and we have a lot of other, small planets that are similar in size. They are known as trans-Neptunian objects, part of what is called the Kuiper Belt. So these are things that are beyond Neptune, trans-Neptunian. The largest is Pluto and its moon Charon. They are considered minor planets or dwarf planets. They're not actual full-fledged planets. And maybe you did or maybe you didn't know, but Pluto was considered the 9th planet until 2006. So when I was in college, Pluto was still considered a planet. And we actually had a debate back then about whether or not it should be considered a planet because it's so different from all the other ones. So, to summarize, I want you to ask yourself a couple questions. So what are identifying characteristics of terrestrial planets? What makes terrestrial planets terrestrial planets? And what are some identifying characteristics of the gas giants? You might also see them referred to as Jovian planets.